You run the same coding job through DeepSeek V4 Flash and Kimi K3, and one bill is 54 times bigger than the other. That gap doesn't show up in the marketing, it shows up in your invoice. DeepSeek V4 Flash is the open, cheap, local runnable workhorse. Kimi K3 is a frontier giant built for the hardest agentic coding. The question is which one you should actually pay for. Test 1, Unit Economics. I expected the objection here. Yeah, Kimi K3 claims a greater than 90% cache hit rate on coding, so the effective input price drops. Sounds good on paper. Output tokens are where the real money goes when you're running agents, though, and that number doesn't cache. So watch what happens when you put the output prices side by side. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Pulled the official API pricing for both, and DeepSeek V4 Flash output runs at 0.28 per $1 million tokens. Kimi K3 output is $15 per million. Even with Kimi's caching doing its best work, its effective input cost is still around 0.75 per million, which is roughly 5 times Flash's cache miss price. DeepSeek has flagged it'll raise prices at some point, but no new rate is set yet, so these are the live numbers. DeepSeek V4 Flash takes cost, and it's not subtle. 54 times cheaper on output is the answer to the title question, and it lands right here in test 1. That puts DeepSeek V4 Flash 1, Kimi K3 0, and the caching argument doesn't close a gap that wide. I've been living inside these models long enough that a pricing page surprise genuinely ruins my Tuesday. Drop a comment below if a token bill has ever caught you off guard the same way. Test 2, Coding and Agentic Performance. The objection I kept hearing was, okay, Flash is cheap, but if it can't close a hard agentic ticket, cheap doesn't matter. Terminal Bench 2.1 is the benchmark that bites here, because it measures multi-step agent tasks, not toy completions. So let's see what the scores actually say when the tasks get hard. On Terminal Bench 2.1, Kimi K3 scores 88.3 against DeepSeek V4 Flash's 82.7, a 5.6 point gap that clears GPT 5.6, Sol, and Claude Fable 5. On BrowseComp, Kimi K3 leads again at 91.2 versus 85.9. Flash does score 79.0 on SWE verified, where Kimi K3 has no directly comparable published figure, so that one goes to Flash on the evidence available, but the agentic story is clearly Kimi's. Now, Flash's 91.6 on Live Code Bench is genuinely strong, and SWE verified at 79.0 is nothing to dismiss. The gap is real, but not a blowout on every single metric. Still, when you need an answer fast on the hardest multi-step agentic work, Kimi K3 is the one sitting at the top of the leaderboard, and that's the decisive call here. Kimi K3 takes coding and agentic performance. It tops Terminal Bench 2.1 and BrowseComp, and I didn't expect the margin over Flash to be that consistent across multiple hard benchmarks. That ties the scoreboard. DeepSeek V4 Flash 1, Kimi K3 1. Test 3, Tokens per second. The number that matters here is 32.0. That's Kimi K3's official API throughput. When you're running an agentic loop that needs to stream thousands of tokens per turn, a slow model is a broken pipeline, not just an annoyance. Speed is the thing that determines whether your agent finishes in seconds or minutes. I pulled artificial analysis numbers for both. DeepSeek V4 Flash runs at 122.9 tokens per second on its own API, and Kimi K3 manages 32.0, roughly 3.8 times faster for Flash. On Makora, Flash hits 234.8 tokens per second, which is over 7 times Kimi's official speed. Locally, Flash is usable on a few GPUs. Kimi K3 on a MacBook streams at around 0.6 tokens per second, which is basically a slideshow. DeepSeek V4 Flash takes speed nearly 4 times faster on the official API, and if you need an answer in 60 seconds on a tight agentic loop, it's Flash, no contests. That puts DeepSeek V4 Flash 2, Kimi K3 1. Okay, so we've got context limits and deployment still ahead, and those two dimensions could completely change who you pick, because one of them is about whether Kimi K3 can even run on your infrastructure at all. If the answer is no, the whole coding performance argument collapses, so let's see how that plays out. Test 4. Context and output limits. The failure mode here is real. You're generating a full codebase or a massive refactor, and your model hits its output ceiling mid-file, truncates the response, and your pipeline breaks. DeepSeek V4 Flash caps output at 384,000 tokens. Kimi K3 claims a full 1 million. Whether that ceiling matters depends on what you're actually building. Both models share a 1 million token context window, so on input, they're identical. On output though, Kimi K3 can generate up to 1 million tokens in a single response, while DeepSeek V4 Flash tops out at 384,000, and DeepSeek actually recommends dropping to a 384K context when you're running its ThinkMax reasoning mode, so the effective ceiling can be even tighter in practice. For most coding tasks, 384K output is more than enough. The average pull request is nowhere close to 1 million tokens. But if you're generating entire codebases, long documentation runs, or massive agentic outputs in one shot, Kimi K3's ceiling is the one that doesn't cut you off, and that's a real, concrete advantage for that specific workload. Kimi K3 takes context and output limits purely on the output ceiling. I had assumed 384K would be enough to make this a wash, but a 2.6x output advantage for Kimi K3 is a real gap for long-form generation. That ties things up. DeepSeek V4 Flash 2, Kimi K3 2. Test 5. Deployment and modality. The concrete failure mode, you decide to self-host to cut API costs, and you find out Kimi K3's checkpoint is 1.56 terabytes and needs a supernode with 64 or more accelerators and roughly 1,180 gigabytes of VRAM. That's not a server rack you spin up on a Friday, so let's talk about what it actually takes to run each of these. DeepSeek V4 Flash is MIT licensed, weighs in at around 304 billion parameters, and runs on a single workstation at roughly 48 gigabytes of VRAM and FP8. I ran it at about 98 tokens per second on 4 CMP 170HX cards. Kimi K3 uses a restrictive custom license, its checkpoint is 1.56 terabytes, and local deployment is supernode scale only. On multimodal input, Kimi K3 does natively handle image and video. Flash's core is text only. DeepSeek V4 Flash takes deployment, MIT license, modest hardware, VLLM support out of the box, and Kimi K3's multimodal edge doesn't offset, needing a supernode just to run it. That's the final score. DeepSeek V4 Flash 3, Kimi K3 2. Alright, so Flash wins on cost at 0.28 per million output tokens, speed at 122.9 tokens per second on its own API, and up to 234.8 on Macora, and deployment with an MIT license that runs on a few GPUs. Its reasoning modes let you right-size compute to the task, which means you're not paying frontier prices for simple completions. Kimi K3 wins on coding performance, topping Terminal Bench 2.1 at 88.3 and Frontier SWE at 81.2, beating GPT 5.6, Sol, and Claude Fable 5. It outputs up to 1 million tokens in a single response for massive codebase generation, and it natively handles image and video input, so vision-in-the-loop workflows are a real option without any extra tooling. If you're doing practical coding work at any real volume, pick DeepSeek V4 Flash. 54 times cheaper on output is the number that closes this debate. Kimi K3 is the right call only if you're running frontier-level agentic pipelines and you already have the supernode infrastructure to back it up. One thing the docs don't surface, Kimi K3's consumer API plans run up to 115 borrows per month, but those plans hit quota limits that users are already calling out as frustrating, strong capabilities locked behind a ceiling that cuts off real workflows. That quota wall is a completely separate problem from the API pricing, and it's worth checking before you commit. If Kimi K3's coding scores got your attention, you'll want to watch the Qwen 3 coder versus Kimi K3 comparison next. It's a really interesting matchup because Qwen 3 coder is gunning for the same agentic leaderboard spots, and the cost story is completely different again. That video is right here.